University of Arizona researchers are trying to tackle the massive challenge of climate change with something small, algae.
That's right. 9 on your side's Ryan Fish joins us here live in studio. Ryan, they say growing this on a really large scale could take carbon emissions out of the air, and that would help alleviate that in our atmosphere.
Yeah, that's right. And U of A researchers say even if we drastically cut our carbon emissions, we'll still end up producing at least 5 billion tons of carbon dioxide every year for the next several decades, because things like airplanes and cargo ships rely on fossil fuels and they can't be battery powered just yet. So they're looking at a way to take that CO2 out of the air by using something that already does that naturally.
We have been injecting carbon dioxide at a rate that far exceeds what Earth can extract.
Daniel Apai studies the potential for life on other planets. But he found a possible climate change solution here on Earth, in our oceans, a type of microalgae known as coccolithophores.
Over the past hundreds of millions of years, these microalgae have been an important part of the carbon cycle on Earth. They have been extracting carbon dioxide from the ocean and transforming it into calcium carbonate shells with which they kind of protect themselves. It's like little shields around these unicellular organisms.
Joining the cause, Professor Joel Coelho, who designs photobioreactors for growing microalgae.
And that's the aim here, is to mass propagate the cells so that you can really remove a significant amount of carbon from the atmosphere. And you're going to be producing these plates, which are calcium carbonate, and that can be used as construction material to make this economically viable and feasible, because that's very important.
Coelho says these microalgae grow faster than trees and can be more efficient at removing carbon.
So eventually they'll start to become this dark green color. This is what we're looking for.
Jack Welker tinkers with different coccolithophores to optimize their growth rates.
So every species, strain we get grows at a different rate. So it's all dependent on light intensity, temperature, nutrient considerations, and where these cells originated from.
They start in these small flasks with the goal of eventually mass producing them in large bioreactors.
We need to hurry up. We don't have, the planet doesn't have much time. We know that the process works, but we need to scale it up.
Their target is to remove 1,000 tons of carbon dioxide from the atmosphere within the next 4 years.
But we need to scale this up by a further factor of 1,000 to have an actual impact that, that has any effect.
Right now, Apai's team includes only a handful of researchers. But like the algae, they hope to keep growing, both in people and in funding.
You know, this group formed last year. They say computer models first proved that this method could work, but the algae in that lab, it's only about 1 month old, so it's still very early in the process. But Pat and Heidi, potentially huge implications down the road if this ends up being successful.
Very promising, at least.